Hey there, Internet. So I'm going to start working on getting my V-blocks back and making a proper arm mount for this. So I bought this piece of ground rod, 25 millimeters, and I have some bearings I think I'm going to use for the sleeves because they're much more precision than I can do. It seems like the distance from the center of this to the center of the rod is about 150 millimeters. And the arc should coincide with the center of the spindle, I believe, but I'm not 100% sure. The first thing I'm going to make is the holder blocks for this. So I need to make a bearing pocket, not for this bearing, but for the smaller one. And then I need to make some split cotters to clamp the left side. The right side, I'm sorry, the right side. The left side is a lot more complicated. It needs to be able to feed in and out as well as rotate. So I need to put some bearings on the end that have a little bit of preload on them so there's no slop. And then I need a traveling nut that's going to allow it to feed in and out. So there's about 10 components on this side. But the end block, the thing that's just going to hold it, I believe I can make that now. And if I put the lock at this end, that'll work. So I think short term, I don't know if I'm going to keep it on this table or if I'm going to make this whole assembly. But I want to get my V-blocks back, so I need to make those bearing. I guess you'd call them pillow blocks. I guess that's what they'd be. They're a little more complicated than pillow blocks. So I got this piece of stock. I think it'll work. The big challenge that I have is I've got these annular cutters, but the shank is 40 or 19 millimeters, and my mill, it just really, the motor's not strong enough to drive something like this. It's let out a tiny bit of the magic smoke a few times when I've tried to do bigger tools. So I have no way to chuck it up in my drill press, which I'm less worried about ruining the spindle motor for. So the ultimate in yak shaving would be to figure out a way to hold the part in the lathe and use the lathe to do it. The problem with using this material is I need a cutter that'll cut 40 millimeter thickness, and I don't have my R8 spindle hooked up yet. So I'd need to either get the R8 spindle hooked up and working, and then put a tool into the R8 collet, which would be long enough to do this. So that would be one option, which is a bunch of yak shaving. The second option would be I could make an adapter for this to put it in the drill press. So that's a bunch of lathe work, more yak shaving. So it looks like I got to shave a yak if I want to use this material. I need at least, I'm going to say at least 20 millimeters. And splitting this is also more machining and yak shaving that I don't want to do. So yeah, I got to think about this one. I think I'm going to use this and split it in half. So I'll my rougher, my 6 millimeter rougher, I don't really even have any larger tools that are 40 millimeters. So I can't interpolate a hole unless the stock's less than 25 millimeters. So I'm going to use a 25 millimeter tool and then just split this down the middle. Not quite square. Good enough. So I skipped a step. I need to drill a hole through here for the split cotter, and I want to install the split cotter in here so that when I do the bore, the radius of the bore is cut into the split cotter. The yaks are out in full force. So I I didn't have this motor on. I've been meaning to redo some of the CNC stuff for this lathe, and then and also to get the electronic lead screw up and running again for this. So because I have the collet chuck on that, and this has a regular chuck on it, I thought to myself, well, I'll just put the motor on this, and then I can go ahead and cut a piece of brass and then turn it down to the right, at least on the, turn it down to a radius, and then I could either put it in the other lathe or finish it up on here. I could use aluminum for the split collet, but I really want to use brass. Unfortunately, the brass that I have is 10 millimeters. Scribed a line on here, and I just was going to take it over to the bandsaw. However, the last time I had problems with the bandsaw, I had to put a new bolt in here because this was stripped out, and there's only this little tiny 1/16 inch bit of metal here for that to thread in. So I snuck a bolt down in there, but the problem is now this won't seat low enough for me to use the table for the bandsaw, and I can't cut the brass without the table for the bandsaw unless I do something wonky with this setup. So I I either need to notch the casting out so that the bolt can sit down to where it originally sat, or do something else. I don't know. Maybe I'm almost even thinking about resorting to cutting that with a hacksaw, but I'm not very good with a hacksaw. Yeah, this is I'm 3 yaks deep. All I really want to do is get a round piece of brass and bore a hole and secure it in there so that I can cut the bearing seat. Okay, I got this back on here. It's clearing when it goes down now. I just changed the bolt so it wasn't quite as bad as I thought it would be. So the first yak has been slain. Now to make some round brass out of some square brass. I haven't looked, but I'm guessing that the cameraman got the back of my shoulder for that whole thing. So I get 2 chances to get this right. Hopefully it's square enough to chuck. I forgot that this is a 3-jaw. I have a 4-jaw on my other vise. I'm gonna try it anyway and see how it works and see how good I got it in there, I guess. That's not it. Oh boy. Alright, so the first yak I need to display. The putting the motor on the other lathe, that really didn't need to happen. So I think this is going to work just in this junky collet that's not accurate anyway. It is round. Do the other one while I have it all set up. I paused it at the wrong time. I don't know if you can tell, but the workpiece should not be sitting on top of the cutter. Maybe I was a bit too aggressive there. Oh, yeah, that's probably not good. Let's see. Cutter seems okay. The workpiece looks like it was cut by the cutter. And that scared the crap out of me. It was quite loud. It's a shame I didn't get it on camera. All right, so this time I'm going to use the tailstock. Not good sounds. I'm just a few over. Feels like I'm going to screw this up at any moment. Two over, it says. I guess I'll go back. Two under. I'll take that. So the big question that I have for myself is how big do I make the bolt for the cotter? Initially I was thinking 5 millimeters, but that only leaves a 1.5 millimeter wall. And I need to have something for the cotter to bite into. So if I do 4 millimeters, that'll give me 2 millimeters of bite, which is probably enough for what I'm doing. Not really sure. I have to go look at the CAD again. So I've got a hole with the shoulder. So there's going to be an 8 millimeter part that's going to go and sit down against that shoulder. And then what I'm going to do is I'm going to ream around. I'm going to bore the 25 millimeter hole for the shaft, and that's going to cut a very slight radius in this piece. And then I'm going to chop it off. And it's going to have a 4 millimeter through bolt. And then on the inside of this, it's going to be threaded for 4 millimeters. So when the shaft is going to be running through here, this part is going to push on that shaft and cinch it into place as a locking collar. It's called a split collar. Well, I was thinking to myself, it's kind of late. You're tired. Maybe you shouldn't do this. And this happened. So this is a completely ruined probe, and the reason it's ruined is there's no way to tell gerbil that you're in a probing routine. So I didn't quite make it past this edge, and so when it went down, the probe went off. Gerbil didn't care. Gerbil wasn't looking at the probe. There's no way to tell it that you have the probe in the spindle and you're doing something that could destroy something. So it just ignores it, and so I didn't have a chance to stop it. There's just nothing I could have done. The probe is clearly triggered, but gerbil doesn't care. So I really, really wish there was a way that you could just tell gerbil, hey, I'm in the middle of a probing macro. If the probe triggers, stop everything, because you're going to have this happen. Well, after crashing my probe and then seeing how much stick out, I can't get the tool in there anymore. I can't imagine anything good's going to happen here. But let's run it and see. A little paper thin thing there. So the only other cutter I have that's long enough to do this, let me just double check that it is in fact long enough to do this, barely, is this straight flute cutter. I don't know what the surface finish is going to look like. This might be a huge mistake, but it is what it is. So what is that? Okay, the moment of truth. I mean, it's real close. It's not close enough to go in, though. The moment of truth, part 2. It seems a bit tighter this way. And a bit loose this way. And that's not something I can fix other than just making it more of an oval. If I press a bearing into that, I'm just going to press the bearing in an oval shape, and ovals don't wear well in bearings. So the caliper says it's under by 1/10 of a millimeter. That seems like a lot, but that's kind of what the calipers were showing. All right, so here it is. My stock, I thought this was going to be 48. It's 55, so the facing didn't finish. The facing is awful. I mean, there's really no other way to describe it. It's just, it's not flat. This fits, but what I did here, it was slightly oval, meaning that this was thinner than this. This seems to be the right dimension. The bright idea I had was, we'll just compensate for it by changing the number of steps. And I had moved it off to the side when I did that, so I changed it. And then I realized that when you change it, like, the whole coordinate system is all messed up. Everything is messed up. So you have to rehome it. You have to reset gerbil. Bad things happen when you change the number of steps and you don't rehome and you don't reset. So it fits in there, but it's not it's not a good fit. Now here's the saving grace here, right? I have Loctite sleeve compound, and so I can just press this in with that, and that sleeve compound will hold this thing in permanently, and it'll never move. It goes in. Hopefully the bearing isn't deformed. I think this will be good enough. My Z wasn't really that far off, as you can see here. I mean, I think this is yeah. that was an easy fix. So I just have to deburr it. I want to see if the bar fits. It's too tight. So I think what I should have done is, instead of changing the step count, I should have just programmed it loose, a looser fit, and use the sleeve compound. I don't think this has any burrs on this end. Let me try the other end. This really shouldn't be tight. This should be a sliding fit. And again, I mean, I can bore this out on the milling machine. I can put it in the lathe. I mean, there's a whole bunch of options I have to open this up, but it is a bit disappointing that the program didn't come out the way I wanted in 16 different ways, and I managed to destroy my probe. That was very disappointing. But the surface finish actually looks good inside, not on this facing job. I really don't know what happened there. It's just completely inconsistent. Lots of cutter deflection, I guess. But even the roughing cutter surface finish isn't that bad. But yeah, I think this final bore, it looks good. It's just not round. So will the part work? Yeah, I don't have to throw it in the trash, but it's not a good part, and it's a bit disappointing. Well, this is part one. I got to make another one of these. Hopefully I'll learn some lessons. And once I get these two made, I have to think about the surface. I have to think about making a plate or something and putting bolts in here to firmly attach it. So yeah, that's part one. Stay tuned for part two. I'm sure I'll break more of my machines and probably drop a few F-bombs and break some cutters and find some yaks to shave. So stay tuned. Thanks for watching. Bye.